I want you to think about that precise moment when a favorite app just inexplicably hangs.
Oh, yeah, it just completely freezes up on you.
Right, you pull down to refresh and you get that endless, mocking, spinning wheel.
The wheel of death, yeah.
Exactly. And everything in our digital workflow feels so instantaneous these days that we tend to treat the internet like some magical, invisible ether that's just all around us.
Right, like it's just in the air.
Yeah. But the reality is entirely different. I mean, the internet is a physical, rigidly engineered, and surprisingly fragile infrastructure.
It absolutely is. I mean, people forget it's millions of moving parts.
Yeah.
You've got these massive warehouse-sized data centers out in the suburbs, thousands of miles of submarine fiber optic cables.
It's just wild to think about.
It is. And when one tiny, seemingly insignificant cog slips, the entire machine can just grind to a terrifying halt.
Which is exactly why we are dedicating today's deep dive to the invisible backbone of that infrastructure, the cloud.
The almighty cloud.
Right. So we've compiled a stack of actual AWS post-incident reports, engineering postmortems, and public outage documentation.
Some really fascinating reads in there.
Truly. And our mission today is to unpack 3 major Amazon Web Services outages to figure out exactly what broke under the hood and, see what these digital disasters reveal about systemic resilience.
Because when a major cloud provider has a bad day...
That's a really bad day for everyone.
Exactly. It doesn't just take down a single website. It takes down a massive, highly visible slice of modern life, just all at once.
Yeah, I always think of the cloud like the electrical grid.
Oh, that's a good comparison.
Right. You flip a switch, the lights come on, and you never think about the power plant, or the step-down transformers, or the local substations.
No one thinks about substations until they blow up.
Exactly. We only ever acknowledge the electrical grid when the neighborhood goes pitch black. And to understand just how incredibly fragile this digital grid can be, we really need to start at the foundation.
Yeah, we have to go back a bit.
All right, we're going back to 2017 to look at how a simple, everyday human action brought down a massive chunk of the digital economy.
Ah, the infamous 2017 S3 outage. I mean, it's basically required reading for any systems engineer at this point.
Totally. So let's set the scene. An AWS engineer is just, sitting at their desk, debugging a slow billing system.
Just a normal Tuesday.
Right. And they're working in a specific server region called US East 1. Now, for anyone who hasn't built infrastructure before, US East 1 in Northern Virginia isn't just another data center, is it?
No, it's essentially the mothership.
The mothership.
Yeah, it is the oldest and consequently the most heavily used AWS region on Earth. I mean, it's the default deployment zone for countless companies.
So if you don't specify, that's where you go.
Exactly. If you spin up a new service and don't explicitly tell AWS where to put it, it's probably going to US East 1.
Okay, so our engineer is working inside the mothership. They run a command line tool that's intended to remove just a small handful of servers to clear up this billing issue.
Seems simple enough.
But they enter the wrong input. One typo.
Ouch.
Yeah. And instead of gracefully pulling down a few internal machines, that command completely wipes out a massive portion of the index subsystem for S3 in that region.
And we should probably clarify what happens when the index subsystem goes down, because S3 is object storage, right?
Right.
It holds images, database backups, application binaries.
So it's basically the hard drive for the internet.
Exactly. So when the engineer accidentally deleted that massive block of index nodes, the data itself wasn't actually erased.
So the files were still there?
They were still there, but S3 essentially forgot where all that data was stored.
Oh, man.
Yeah, it lost the map.
Which means any application trying to load an image, fetch a file, read a database backup, it just suddenly hits a brick wall.
Instantly.
Within minutes, Slack stops working, Airbnb goes down, Adobe goes dark, even the AWS Service Health Dashboard.
Which is the literal status board designed to tell you if AWS is broken.
Right. Even that turns completely red. I mean, the chaos had to be monumental.
Oh, it was a very bad day for a lot of engineers.
I bet. But, the detail in the postmortem that absolutely floors me is that it took 4 agonizing hours to restore the system.
Yep.
And the reason why. The recovery tools required to fix S3 were hosted on S3.
Which is just, well, it's a textbook example of what we call a blast radius containment failure.
A blast radius containment failure.
Yeah, I mean, human error is a given, right? You can never completely engineer typos out of existence.
Sure, people make mistakes.
But the system design failed to isolate the impact of that typo. They had a circular dependency.
Meaning they needed S3 to fix S3.
Precisely. The tools needed to restart the storage nodes required pulling configuration files from the very storage nodes that were just knocked offline.
So they essentially built the ship's emergency bilge pumps to run off the main engine.
Exactly.
If the main engine floods, your emergency pumps are completely useless. It's
Yeah.
exactly like locking your keys in your car, but realizing your spare key is locked inside the glove box.
It completely defeats the entire purpose of having a spare key.
Right. But wait, I have to push back on the architecture here for a second.
Yeah.
We are talking about AWS.
Yeah, the biggest player in the game.
How on earth did the engineers there allow such a glaring single point of failure to exist in their own internal tooling?
Well, it really comes down to institutional assumptions about scale.
What do you mean?
So in the post-mortem, AWS acknowledged they assumed S3 was simply too massive and too distributed to ever experience a region-wide systemic outage.
They thought it was literally too big to fail.
Exactly. So they built their operational tools on top of it, treating S3 as an infallible bedrock layer.
Wow.
And the realization they had to come to, and really the lesson for the rest of the industry, is that you cannot rely on runbooks alone.
Because a runbook assumes you know what's going to fail.
Right. You can't write a runbook for the foundational layer of the internet just vanishing beneath your feet.
So AWS basically had to completely re-architect their administrative tools.
They did. They aggressively partitioned them. They implemented what's known as cellular architecture for their tooling.
Cellular architecture.
Yeah, ensuring that the recovery systems are entirely decoupled from the infrastructure they are monitoring and repairing.
Got it. So keeping them totally separate.
Exactly. They fundamentally altered the blast radius, ensuring a single administrative command can never span that much capacity again.
Okay, so AWS learns a hard lesson about tightly coupling their tools.
A very hard public lesson.
Yeah. But if we pivot from the cloud provider's tools to the architectural choices that everyday businesses make, it brings up an even bigger problem.
It really does.
Because if relying on a single underlying service is risky, choosing to put all your company's infrastructure in a single geographic location is a massive gamble.
A gamble a lot of companies take, unfortunately.
Which brings us to the documentation from December 22nd, 2021.
The holiday outage. The timing on this one was just brutal.
It's peak load. Millions of families are home, streaming movies, last-minute shoppers are hammering e-commerce sites, and suddenly US East 1 goes down again.
The mothership fails again.
Right. But what's so striking about the 2021 postmortems is how violently this digital failure bled into the physical world.
Oh, absolutely.
Ring doorbells stopped authenticating. Smart thermostats went dead. People couldn't turn on their living room lights or even control their Roomba vacuums.
Yeah, it really highlighted the reality of the Internet of Things.
How so?
Well, your smart home isn't actually smart locally. It's completely dependent on a constant real-time tether to a server in Virginia.
So the brain is in Virginia, not in your house.
Exactly. When that connection drops, those physical devices become incredibly dumb paperweights.
That's terrifying.
And you know what the true irony of that specific outage was?
Amazon's own delivery logistics network completely ground to a halt.
Right. During the absolute peak of the holiday delivery rush, warehouse workers couldn't scan packages.
Oh my.
Delivery drivers couldn't load their route maps, all because Amazon's real-world logistics operations were heavily dependent on the broken region.
The ultimate snake eating its own tail.
Really was.
But let's look at the mechanism here. I mean, how does an entire region just collapse during a holiday rush? The reports cite a localized network overload, but what does that actually mean under the surface?
Well, it wasn't just external user traffic, like people buying gifts. It was an automated scaling activity inside the data center that triggered a latent bug in the devices managing AWS's internal network backbone.
So an internal bug caused it.
Yeah. And this caused massive internal congestion. And in distributed systems, network congestion breeds what we call a retry storm.
A retry storm. So a client tries to connect, fails, and immediately tries again.
Exactly. When an application can't reach a database, it doesn't just give up and go away.
Right. It's programmed to keep trying.
The code is written to automatically retry. So now the congested network isn't just dealing with the original traffic.
It's dealing with the original traffic plus thousands of frantic retries.
Yes. Thousands of automated, frantic retry requests hitting the hardware simultaneously. It creates a cascading failure that just chokes the entire internal routing system.
It's incredible that so many massive brands like Disney, iRobot, Ring, They all went down because they were entirely dependent on this one facility.
It's surprisingly common.
It really feels like putting all your fragile holiday presents into one thin shopping bag. You hit one bump, the bag rips, and everything just shatters on the sidewalk.
That is a perfect analogy.
But I have to ask, doesn't this defeat the entire premise of the cloud? We're sold this vision of a highly decentralized, globally distributed network.
Yes, the marketing pitch.
Right. If tech companies are still architecting their apps as if they live in one single highly vulnerable data center, what are we even doing here?
Look, it's one of the most heavily debated topics in cloud engineering. You're talking about multi-region architecture.
Multi-region?
Yeah. To prevent what happened in 2021, companies should distribute their workloads.
Okay, so spread it out.
Exactly. If US East 1 goes down, your system should instantly detect the failure and automatically route user traffic to US West 2 in Oregon or a region in Europe.
So why is it that seemingly no one does that? If it prevents a massive holiday outage, it seems like an absolute no-brainer.
Because building true active multi-region infrastructure is brutally difficult and incredibly expensive.
Really? Why is it so hard?
It's fundamentally a physics problem. Data takes time to travel across the country.
Okay.
If a user in New York updates their profile and you need that data immediately synchronized to a backup server in Oregon before you confirm the save, you introduce latency.
So the app feels slow to the user.
Exactly. You end up literally fighting the speed of light. Engineering around that latency, like managing data replication without corrupting the database, it requires massive, highly specialized engineering teams.
So companies look at the complexity, they look at their AWS bill, and they just decide to take the risk.
Exactly. They run the math. They bet that a total regional failure won't happen often enough to justify the millions of dollars it costs to run a multi-region setup.
Wow.
The stark lesson that came out of 2021 was a reiteration of the shared responsibility model.
Which is what, exactly?
The cloud provider is responsible for the resilience of the cloud infrastructure, but the customer is solely responsible for resilience in the cloud.
So they chose the single shopping bag.
They did.
Okay, well, total regional failures are dramatic, they are frustrating, but at the very least, they are definitive, right?
Yeah.
You get a hard error message, the server is completely dead.
And in the world of systems engineering, a total failure is actually much easier to diagnose and recover from than a part failure.
Right.
Really.
Which logically brings us to the most insidious outage in our stack of reports today. Let's move to 2020.
Oh, boy.
Oh, yeah, this wasn't a typo, and it wasn't a network traffic retry storm. This was a deep underlying failure in a service called Amazon Kinesis.
Yeah, Kinesis. It's a massive data streaming service. It basically ingests, buffers, and processes gigabytes of data per second for real-time analytics.
Right. And according to the incident report, a really subtle error in Kinesis triggered a massive domino effect across a slew of other foundational AWS services.
It just kept spreading.
Yeah, we're talking about IAM for access management, Cognito for authentication, CloudWatch for monitoring, and Lambda.
Oh, the heavy hitters.
Exactly. This wasn't a hard crash. This was a cascading partial failure. So what actually happened at the server level here?
Well, this is where we get into the hidden dangers of microservice architecture.
Okay, lay it on me.
The root cause in Kinesis was an operating system limit. Specifically, a thread limit.
A thread limit.
Yeah, the front-end servers that handle incoming data streams basically hit the maximum number of processing threads allowed by the operating system.
So the server basically hits a hard ceiling and panics.
Precisely. The OS throws an error, and the server software restarts itself.
Okay, that makes sense.
Yeah. But remember, the overall incoming traffic hasn't stopped.
Right, the data is still pouring in.
Exactly. So while that first server is restarting, the load balancer shifts all its traffic to the remaining healthy servers.
Which pushes those remaining servers over their thread limits.
Yes. It creates what we call a thundering herd.
A thundering herd.
Wow. One by one, the servers panic, restart, come back online, immediately get crushed by the backlog, and then panic again.
That is brutal.
It is. But the critical issue isn't just Kinesis failing. It's how modern cloud applications are built using tightly coupled dependencies.
Right. Everything talks to everything else.
Exactly. Take Cognito, which handles user logins and authentication. It relied heavily on Kinesis to process its operational logs.
Wait, a logging failure took down an authentication service?
Yes, because of how the dependency was engineered.
That seems backward.
Well, the authentication service was designed to essentially say, if I cannot successfully write my audit logs to Kinesis, I will pause and stop processing logins entirely.
Oh my gosh.
Yeah. So a data streaming issue morphs into a complete lockout for end users across thousands of completely unrelated applications.
That is wild. But why is a partial failure like this so much harder for engineers to handle than the total blackout we saw in 2021?
Because a partial failure lies to you.
Lies to you.
Yeah, the system doesn't know it's dead. In a hard crash, the network connection drops instantly, and your backup systems can immediately take over.
Right, it's clear cut.
But in a partial failure, the servers are constantly restarting. They accept a connection, hang for 30 seconds, and then drop it.
So it looks like it's trying to work.
Exactly. Data gets partially written. Routing logic gets confused. The symptoms are constantly shifting around, making it exponentially harder to pinpoint the actual root cause.
In reading through this report, the most terrifying aspect for the incident response team was what happened to CloudWatch.
Oh, this is the worst part.
Yeah, CloudWatch is AWS's internal monitoring and alerting platform, the literal dashboard the engineers look at to see the health of the servers.
Their eyes and ears.
Right. But because CloudWatch also relied on Kinesis under the hood, it was caught in the exact same cascade. It broke.
The engineers were flying completely blind.
I can't even imagine the stress.
They were deploying fixes, they were restarting clusters, but their telemetry data was delayed or just completely missing.
It's like trying to fix a massive, highly pressurized, leaky water pipe in your basement while wearing a blindfold, because your emergency flashlight relies on a hydro generator powered by the exact same broken water pipe.
That is a phenomenal way to visualize it.
You have zero visibility, and your diagnostic tools are fundamentally compromised by the very problem you're trying to solve.
Exactly. And the architectural mandate that came out of this 2020 outage is the absolute necessity of independent out-of-band monitoring.
Out-of-band monitoring, meaning totally separate.
Yes. Your telemetry and alerting tools cannot share fate with the systems they monitor. They have to operate on completely isolated infrastructure pathways.
So if the ship goes down, the distress beacon needs its own battery.
Perfect way to put it. AWS had to completely rethink their internal dependencies to ensure that a failure in a logging or streaming service could never blind the operators again.
It is genuinely staggering to step back and look at the sheer complexity we've covered today.
It's a lot to take in.
It really is. I mean,
Yeah.
We looked at a typo that accidentally erased the internet's index map, taking down half the web because the recovery tools were locked inside the broken system.
The glove box key.
Right. Then we explored a localized network retry storm during a holiday rush that paralyzed smart homes because businesses refused to pay the high cost of multi-region redundancy.
A single shopping bag.
Exactly. And finally, we unpacked a subtle OS thread limit that created a thundering herd, completely blinding the engineers because modern microservices are just too tightly coupled.
Yeah, flying blind in the basement.
3 distinct outages, completely different root causes, but they all hammer home the exact same realization for you listening throughout her. The internet is an astonishingly fragile house of cards.
Frankly, when you understand how many micro interactions are required just to load a single web page, it feels like a mathematical miracle that it works as often as it does.
It really does feel like a miracle.
Yeah.
So after poring over these postmortems, after looking at the thundering herds and the blast radii, I have to ask you directly on behalf of the listener.
Okay, go for it.
Should we actually trust the cloud with our critical infrastructure?
That is the ultimate question, isn't it?
It really is.
And looking at these documents, the honest answer is nuanced. The cloud is not magic. At the end of the day, it is just someone else's computer.
Right.
Trusting the cloud does not mean believing it has 100% uptime and will never fail.
Because it will fail.
Exactly. That is a dangerous, fundamentally flawed illusion. True trust in the cloud means architecting your environment with the absolute assumption that it will fail.
You have to design for the disaster.
Exactly. You implement decoupled services. You enforce strict blast radius boundaries. You invest in out-of-band monitoring. You don't trust the cloud provider to build an unsinkable ship. You trust the life rafts, the watertight doors, and the failover mechanisms that your own team has rigorously tested.
That makes total sense.
The biggest operational mistake you can make is treating cloud infrastructure like an infallible, invisible utility. It demands a profound respect for its complexity.
Which leaves me with a final, slightly provocative thought I want to pass on to you to mull over after this deep dive finishes.
I like this.
We've just spent this time dissecting how the most well-resourced, technologically advanced corporations in the world can be completely paralyzed by a single character typo or a tangled back-end dependency.
It happens to the best of them.
It does. And it makes you wonder, what hidden, tightly coupled single points of failure exist in your own life.
Oh, that's a deep question.
Right. Whether it's in your personal systems, your daily routines, or the digital workflows you rely on absolutely every single day without a second thought. Because the next time you pull down on that app and the spinning wheel just keeps spinning, you'll know exactly how fragile that invisible magic really is.